Hey guys, the first thing we're going to do is go ahead and get our reference materials put into our notebooks. So if you will open your journal, hopefully you have a nice pretty header here. Go ahead and flip that first page over. I asked you to save a couple pages in the front, and you are going to put the green reference material that says length on the left side, and go ahead and get a glue stick and glue that down. And then on the right side, it's going to be the one that starts with linear equation. So this is what it should look like. Go ahead and get those glued into your journals. Now we're going to take a look at converting in measurement systems. So the first thing we're going to look at is a problem with the customary system. The problem says, Sally is making lemonade. She needs 8 cups of water, but her measuring cup only has ounces on it. How many fluid ounces will she need for the recipe? So we're trying to see if we need 8 cups of water and we can only use ounces, how many ounces is equivalent to 8 cups of water? So we're going to talk about 2 different methods for solving proportions. Solving measurement systems. We are going to use proportion method, and we're going to use a unit rate method, which we'll actually mainly call dimensional analysis. And you're going to kind of decide which one you like better and use the one that you like better. They're both good in their own ways, and sometimes I like one over another for just the type of problem that it is. So let's take a look here. We're going to start just on the proportion method, so let's go ahead and focus on this one and write along with me on your sheet as we go. The first thing you want to do is write the word ratio. So we want to make sure, just like we know proportions, it's so important to think about our labels. We're considering ounces and cups. Then we're going to set up the proportion. Notice ounces, cups, this is going to be ounces and cups, and this is the short version of ounces. And then we're going to solve for a variable. So if we're looking at this, I would rewrite this here. 8 ounces is 1 cup. And then we don't know how many ounces if we want 8 cups. Now, where do we get this information? First of all, look at the question here. And this is what we talked a lot about in our proportion unit, is how many ounces. That's what we don't know, and that's why our X is ounces. But we also know that she has 8 cups of water, so that's where this ratio is coming from. So where in the world did we get this ratio? Well, if you look at your measurement sheet, it comes right off of your measurement sheet. Right here, it tells us 1 cup is 8 fluid ounces. So for these measurement proportions, your ratios are going to be grabbed off of your reference chart. So I'm going to write 1 cup is 8 ounces directly from my reference chart. So these are actually all different ratios. Now we can just solve this using proportions. In my opinion, you should just do equivalent ratios. So 1 times 8 is 8, and 8 times 8 is 64. So I need 64 ounces if I need 8 cups. And that is one way of converting. Now let's talk about this new method, which is dimensional analysis. According to the state of Texas, I feel like they really are pushing the proportion method because this isn't our proportions unit, but we always want to think of math in a million different ways, and here's just another option for you. So you're going to multiply the given measurement by a unit conversion factor. So that's actually the unit conversion factor from your reference chart. Be sure that your units are diagonal from one another so you can cancel them out. So let's talk about this. Our units here were not diagonal. They were straight across. Ounces, ounces, cups, cups. But if you see here in dimensional analysis, we put cups and cups because we want to be able to actually cancel out those units. So let's take a look. If I want to figure this out, I know that 8, and this is just literally, notice the difference here also, is on the proportion method, I have an equal sign. I want those to be equivalent. On the dimensional analysis side, I don't have an equal sign, I have a multiplication sign. So you're literally just multiplying the ratios as fractions. Again, you pull out 1 cup is 8 fluid ounces. So I know if I have 8 cups, that 1 cup is 8 fluid ounces. So I'm going to go ahead and solve this. I know that cups cancel because if I were to multiply this across, isn't cups divided by cups just nothing? Because they cancel each other out. So I cancel these, and then 8 times 8 is 64, and the only label I still have is ounces. So I actually was able to do this much quicker than a proportion, but we did take a little time to set it up. Let's look at problem number 2. Jerome has a 2-gallon jug of orange juice. He wants to know how many ounces are in a 2-gallon jug. So we have a situation here where you're actually going to convert between something that is not on your measurement chart. So I don't actually have a beautiful conversion of gallons to ounces. I have gallons to quarts, quarts to pints, pints to cups, and cups to ounces. I don't have the conversion of gallons to ounces. So we're actually going to have to do a couple of different proportions to solve this, and then we'll use dimensional analysis to show a different method. So let's check it out. Remember, in proportions, you want to find your labels. So I know that I need to go from gallons to cups. I'm sorry, actually, let's take a look at our measurement chart. My ultimate goal is to go from gallons to gallons, and I don't know how many ounces. So I want to do ounces. This is my ultimate goal. So we need to figure out how to get there. If I look at my measurement chart here, I know 1 gallon, and I'm starting with gallons, 2 gallons, so I actually need to go from gallons to quarts. So I'm going to do my first proportion as gallons to quarts. You know how important labels are, so that's the first thing I'm going to do, gallons to quarts. Well, I know that I have a 2-gallon jug of orange juice. So I'm going to go ahead and say, if I have 2 gallons, how many quarts is that? Well, what do we know about gallons and quarts? That 1 gallon is 4 quarts. So I'm going to go ahead and pull that over here. 1 gallon is 4 quarts, and that's a ratio all on its own, so that needs to be together. And then we don't know how many 2 gallons is. Well, the cool thing about measurement is you're always going to have this unit rate, because these are all literally just unit rates, correct? It's out of 1. Well, if this is a unit rate, then all I really have to do is multiply these, correct? Think about cross product. I would multiply then divide by 1. When you divide by 1, nothing happens. So the reality here is that this proportion just tells me that 2 times 4 is 8 quarts. Well, now I need to take my 8 quarts and make it into pints. So I know 8 quarts is how many pints? Well, if I'm going to make a proportion, I need this equal to the amount of pints. 1 quart is 2 pints. So I know 1 quart is 2 pints. Again, this is just cross product and divide by 1. So 8 times 2 is 16 quarts. I'm sorry, pints, right? We've got to use our labels. 16 pints. Well, I'm not quite at ounces yet, so I need to keep going. So 16 quarts, pints. Oh my gosh, this is why we have to have good labels. Okay, so I know now I need to go from 16 pints, and I need to know how many. Well, I'm looking for ounces, but I can't go there yet. I know pints to cups. So I'm going to say pints, how many cups? Well, I do know that 1 pint is 2 cups. 1 pint, 2 cups. Again, I'm just going to multiply 16 times 2 is 32, and I'm looking for cups at this point. So I've gone from quarts to pints, now I'm at cups, and I need one more transition. So now I need to go, if I have 32 cups, how many ounces is that? And finally, I will have my answer. So I know this needs to be cups and this needs to be ounces, and I go to my chart and I say, if I have 1 cup, I need 8 ounces. So 1 cup, 8 ounces. So I need to do 32 times 8. So we'll just do a little side math. 32 times 8, 16, 24, 25. So 256 ounces. So if I'm looking at the analysis of this, I started with gallons, I went to quarts, then I went from quarts to pints, Then I went from pints to cups, and then I went from cups to ounces. And now I know that 2 gallons is equal to 256 ounces. They are equivalent measures of orange juice. Let's look at this in a dimensional analysis way. The thing I like about dimensional analysis is you don't have to write 4 proportions. So I think that you may enjoy, if you're going from a larger, if you're doing a lot of converting like this one did, then you might enjoy dimensional analysis a little better. So let's check it out. I know that I'm starting with 2 gallons. And the first, and I put equals, but I should put times, right? Because this is not a proportion. So 2 gallons times, and I need the ratio, the first ratio that I know from my math chart. So if I'm looking at this math chart, I know that 1 gallon is 4 quarts. And remember that in dimensional analysis, our labels are always going to be diagonal from each other so that we can cancel them. So we have 1 gallon is 4 quarts. But I can add another ratio here. So I'm going to do the next one I know, and this is, of course, quarts. Well, now I need quarts to be diagonal from my original quarts. And what do I know about quarts? I know 1 quart is 2 pints. 1 quart is 2 pints. Okay, now I need to go from pints to cups. And I know, according to my list here, that 1 pint is 2 cups. And our last one here is going to be cups to ounces. And I know that I have 1 cup is 8 ounces. So if you look down here, we have a very similar situation, okay? And I wanted you to have this in your notes so that you can look back at it if you needed to. So I want just to make this a little more clear, note that each conversion ratio, the numerator of the previous ratio becomes the denominator of the next. So we're talking about gallons, gallons, quarts, quarts, pints, pints, cups, cups, ounces. So this is kind of a very similar question to the one we're doing. So gallons becomes quarts, and then quarts becomes pints until you finally come to ounces. And what you do, if you notice, is if I divide everything by 1, well, isn't that just what we come up with? So this is really just 22 times 4 times 2 times 2 times 8. And you can see that here. 22 times 4 times 2 times 2 times 8 equals 2,816 ounces. Well, let's take a look at it over here. That means I'm really just multiplying 2 times 4 times 2 times 2 times 8. 2 times 4 times 2 times 2 times 8. And I want you to write that down. And then you go through the process of multiplying it all out, and just like the other side, you will receive that this is 256 ounces. All right, go ahead and try the back on your own, taking some time to experience proportional method versus dimensional analysis. You do need to do both methods so that you're comfortable with both, and then you can kind of decide which one you like better.